So everyone here knows the golden rule. The more you can mention large language models and generative AI in your presentation, the more your stock price will rise.
AI, AI, and AI, 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 AI.
It works for a lot of companies, especially those actively engaging the business community with a ton of data. Now, we're used to hearing about these language models, and we're talking about GPT, ChatGPT from OpenAI, Llama from Meta, Ernie from Baidu, Lambda and Palm from Google, and there's a company called Anthropic that has one called Claude, and there are others out there. The truth is, for the world of machine learning, these sorts of models only tackle one aspect of existence, language. Now, don't get me wrong, language is a big and important aspect, but for other types of knowledge, different models have to exist. Previously, models were trained with sets of labeled data. This is a model which would learn cat images from dog images because the training data will tell you whether it's a cat or a dog or a goose or something else. Today, models can be trained on 1,000 times more data due to a concept of self-labeling. This means that the data itself is the label. Take a sentence, remove a word, tell the model to guess what the word is. And in large language models, you can train by using that phrase, removing a word, and what this means is the data is its own label, and there are thousands, millions of documents out there for training. This is the concept of a foundational model, built upon large amounts of self-labeled, or sometimes called in the industry unlabeled. I'm not a big fan of that, but I prefer self-labeled data. Here's a great diagram showing where foundation models are currently being used. Now, here at the bottom two, you see the large language models being heavily used for natural language and code. However, there are others on this list that aren't large language models. Turning molecular data into a foundational model can be used for new medical or chemical discoveries. Process data can be trained into a foundational model for automation. And geospatial data can be used to train a foundational model for sustainability. And by this, which can be extended to weather and other important phenomena. Now, usually a big foundation model doesn't exist on its own. There's a technique in the industry called fine-tuning. You take these large models trained on unlabeled data, and you can provide a small amount of labeled data to optimize the model for a particular use case. This allows each company to individualize its own foundational model, fine-tuned with their unique data to provide value to the business. We see this in large language models today, and it's set to spread to all these other different types of foundation models. If you thought companies investing in LLMs were going a bit overboard, this, it seems, is just the tip of the iceberg. However, fine-tuning isn't the most basic thing to do. Often, there's a need for a business to identify the model it needs, as well as where its own data might be located inside its own infrastructure. You can't just throw random stuff at a foundation model and expect value. So right now, there's a whole ecosystem being built around these fine-tuning strategies, both at the computation level, but also at the can I find my data and is it useful level. After that, it's a case of finding the right form of deployment, whether that's in hardware, software, and then finding where that business value is. Now, there are very few companies equipped to do all of this. We see a lot of companies playing with language models today, but as I stated earlier, the value of foundation models goes well beyond language, and some of that gets lost in the hype of the day. As a business owner, it makes sense to call upon experts to provide A, the models, B, the assistance in data management, C, the fine-tuning capabilities, and D, how the models can be deployed at scale to bring value to that company. So to that end, I've invited a couple of guests onto the channel today to discuss the future of machine learning and how we all, as a society, interact with AI, machine learning, and generative AI. Joining me today are Dr. Mukesh Khare, VP of Hybrid Cloud at IBM Research, and Sriram Raghavan, the VP in charge of all AI research at IBM. Regular viewers of the channel may recognize Mukesh, as he's appeared on the channel a couple of times. Great to see you again, and including an extensive interview. And you should check that out. I'll put a link in the description. Welcome to Sriram, first time on the channel. Good to have you.
Thank you. Yeah. Pleasure to be here.
So the first discussion point I want to bring up is a simple one. Why have we, the industry, seemingly glossed over the fact that there is more than one foundational model? I mean, there are more verticals for foundational models than simply the large language models we keep hearing about. Is it simply that the language models have more immediate business value than others?
Yeah, so I think it's a great question, Ian. I think there's probably two reasons that's the case. One is this technique around self-labeled training, if you will, got invented in language. And so the recipes, the approaches, the examples exist there. So that's driving adoption. And there's a lot of low-hanging fruit, if you will, in applying this for both language, and it's already spreading to code. But as you rightly pointed out, this is just the tip of the iceberg. This technique of taking a piece of data, hiding a portion, telling the model learn, is generalizable. And we're starting to do that already. So at IBM, we've been working with NASA on how do you apply it for geospatial data. We're working on how to apply it to molecular data, how to apply it to security and events data. So I think this is going to come in. What you're seeing today is just a reflection of that's where it got invented. A lot of knowledge, tools, libraries, use cases exist, and there is immediate value. So you're seeing that dramatic adoption.
So in geospatial data, I can imagine taking the weather profile for a given week, and you take out, say, Alaska, and you tell the model, work out what Alaska says and compare it to the real thing.
Right, or you treat a satellite, a piece of satellite imagery across lots of resolutions, and say, I'm going to take a tile, and I'm going to pretend you don't know that corner. Now go predict. And you do it at enough scale, just like you do it at language. Yeah, you're right. And you learn from Alaska, predict somewhere else, and you start to learn. So early days, but the potential is very exciting, very exciting.
I completely agree. I think this field is evolving, and applications are going way beyond language and code the way it's getting started.
So demand for compute is always increasing, and this is just going to make it explode even more. Do we have enough silicon in the world, enough packaging?
Oh, wow. Well, that one part that I completely agree that the rate and the progress in the field of generative AI has really made demand for silicon grow even faster. Because of the need for silicon in generative AI, our industry is predicted, the silicon industry is predicted to become almost a $1 trillion industry.
I saw that.
You saw that? That is exciting because in next few years or by end of the decade, this industry will become such a big industry and such a critical industry. And the entire area of generative AI or foundation model, they are all enabled through the chips. These at the end, chips are the technology which are enabling and making these model run fast, efficiently, get trained, etc.
So on this concept of fine-tuning a foundational model, what is needed from the companies that want a model custom to their use case? And what are the use cases for these custom models that you're seeing?
Yeah, so Ian, I think let's parse the word fine-tuning a little bit, because I think it actually applies to like a spectrum of techniques. Okay. So fine-tuning means that I have a base model. I got it from open source, I got it from a vendor, and now I have data and I want to teach the model either something about my data and or customize it to a task. So one end of the spectrum, which is, you could argue, the least intensive when it comes to what you need to do from a compute, is this whole notion of prompt engineering, which is, I'm going to keep the model as it is, just with 0, 1, or 2 examples. If the model has enough base knowledge, I can get it to do what I want just by showing what I want it to do. That's prompt engineering. Then next comes what's sometimes called prompt tuning, sometimes called parameter efficient fine. It's like lots of words in there. But the point is, I still want to keep the base model as it is. But I'm going to give 10, 50, 100 examples of what I want the model to do. But I don't create a derivative model. All I'm learning is, how do I use that 50, 100 samples to learn how to poke the model to get it to do what I want it to do? So that's like the middle category.
So is that what I'm doing with ChatGPT online?
To some extent, yeah. I mean, when you're simply just asking it a question, it's getting it. You're even probably doing step 1.
Yep.
But if you are actually doing small amounts of label data, you're doing that middle bucket. But then in businesses, enterprises are sitting on more data than a few 50, 100 examples. Then you get into, I'm going to use all of those examples. I may have 1,000 examples. I may have 10,000 examples. And I want to actually create a derivative model that is fit for purpose for a specific task. Why is that interesting? It's interesting because, as Mukesh was saying, these big models are massive. If I have something where all I needed to do is to do one thing well, if I can get an efficient, fit for purpose, easily deployable model, cheaper, faster, quicker, then that's the value that I'm going to get. So I see this whole spectrum. It's going from easy to harder to do. But it also has the thing that if you are willing to invest, fine-tuning will get you fit-for-purpose efficient models, and that's where there's a lot of interest in doing that.
Are you seeing, I was having a discussion on the bus on the way over here with the other analysts about companies especially those with sensitive data, don't want to trust the open source models, the Llama 2s, because they have no guarantee where what that model was trained on. Are you seeing this sort of customer movement into having that? It's almost supply chain security, but for foundation models, right?
It is.
Yeah, it is true, and I will say this whole the whole area of AI is not transitioning from being able to identify cats and dogs to actually going towards being able to do mission critical functions in a business. And that's the change that is happening now, in our industry, and that's why companies who are now counting on AI technology and foundation models to perform tasks for which they need to stand behind and to be able to certify that the data or the model that they are using is something that they can trust. Now the game has changed, and that's where companies like IBM plays a big role, because we have been a trusting company in the space of IT technology for last 100 years, right? In fact, IBM is the only company in the whole world which has survived for more than 100 years.
You've got to get a plug-in.
Yeah, of course we have to get a plug-in because of the fact that we develop technology for business. Our AI is for business. That means what we are doing is making sure that the data that we are using is data that we can count on. It's legal data, it's clean data. The model that we are building with that data is something that we can deploy to our client, and we can indemnify that model. How many companies are capable of doing that? So that's the power. That's where the era of AI has moved from, hey, it's a great thing, cool thing, to it's like critical, and you need it for your business, basically.
It's if you're wondering where they're training their model, it's just on the supercomputer I helped to name, and I will be perennial proud of that. Yeah,
that's correct.
Yeah.
You should watch that video.
Oh, I didn't know that. Okay, that's great to hear.
It's one of the highlights of my career. But back to you're talking about this data, and everybody is scrambling for hardware, for data, for expertise. I mean, IBM does have hardware divisions, but not in the same way it used to. But you now have obviously this AIU for inferencing, different workload training. But yeah, everyone is scrambling for hardware, for data, and for expertise. How do we as an industry or as individual players ensure that we have the right balance when it comes to hardware, data, and expertise? I mean, I'm seeing companies that are leveraging billions of equity buying hardware, or billions of debt as well. And it's like, okay, you've got the hardware, where's your data? Where's your expertise? Or I see companies with data and expertise, but no hardware. It's a term that was popularized in the industry recently was, GPU rich and GPU poor. It's
That's right.
But everybody wants to get into it. So what's the right balance here?
Well, I will say that this industry is evolving and the field is changing too fast.
Yeah.
So you need to be flexible. Okay. And the way we think about it is that as a company, like if you're not like one of the top 5 or very big company, you need to be thinking about how you're going to create value.
Yep.
It's the value creation that is important. Being able to understand how the trends are going and then work with other companies. Partnering is going to be very important in this case, because you cannot just build everything in-house, because as you said, either you're GPU rich or GPU poor. Yeah. Well, you know what, you need to be GPU flexible, right? Depends on the need of the time. You need to work with companies who are working in an open environment. They are trusting environment. They are empowering you to be a value creator, or they're targeted for the work that you're trying to do. So the way we think at IBM is about how can we be partnering with entities so that they can create value rather than just be the user of AI. That's a difference because now with the way the generative AI world is going, is let's just not get trapped into a situation where you're just kind of getting an API access to an AI model, basically, right? So that's the way that gives you all the flexibility that you're looking for. And you can then there are many entities who are willing to partner, and I think this is going to be a world of partnership. Yep. Rather than being able to do everything internally.
So Sriram, everything we've discussed, people think generally in terms of large language models, you know, the fact that there's so many open source, right, and everybody's picking and choosing what they want to use. When we look at foundation models outside of language, things like geospatial, things like molecular, things like automation, do you find that those business use cases tend to be more strict in their requirements? Because obviously large language models being topic of the day, everybody's kind of playing fast and loose. I can imagine the companies that play in the other spaces are pretty strict.
Stricter, but even in the LLM space, as you move beyond sort of, let me experiment a POC, POT, as soon as you go from that to, that POC, POT told me there's possible value here. I can save money, do something faster, provide better customer experience. You do get stricter even in LLMs as soon as you get to production. Then it matters to Mukesh's point. Then they think about flexibility. I need to do this in 2 places. Who's going to help me do it both on-prem in that other cloud? Who's going to help me do this other use case in Europe and also in the US? Regulations, data movement. So I think the strictness comes even in LLMs very quickly as you move beyond POCs in production. And to your point, when you talk about more sensitive data, molecular data, I'm sitting on my own private molecular database. I'm way stricter in talking to a provider and building a model than in LLMs. But it's absolutely a journey of maturity.
Okay. So moving on slightly, there's this concept of full stack, right? In app development, we usually say a person is a full stack developer if they work back end and front end. Right. However, in large language models, it's starting to become the phrase to describe companies who can do foundation and tuning and things like co-prompting as well. Do we now have to have engineers trained in that sort of full stack foundation tuning, co-prompting in the same way we've done with app development?
I will take a slightly different view on this. Okay. The way we look at it, if you look at IBM has always been a full stack company. Like for our mainframe platform, as an example, going all the way from designing our own silicon to building our own system to being able to develop our own middleware to deploy applications on top of it. I think in the era of generative AI, having an end-to-end understanding, and in this case, full stack means, in our view, all the way from being able to understand the silicon that is needed, being able to develop or build those large supercomputers that you have helped us to name, right? And being able to then work with the middleware platform that is needed to be able to deploy these large models in a distributed manner so that you can build them in a reasonable time, and then being able to develop the right algorithm, develop right application, having an end-to-end understanding of the full, that is the real full stack in our view. Okay. And that doesn't mean that you need to do everything yourself. It means you need to have an understanding of everything. And then you partner. Certain areas you're good at, you do that. Certain areas you're not good at, so you partner with the right teams. The fact that me and Sriram are sitting here together, it goes all the way from
hardware to
silicon, solutions and applications.
Everything, between two of, and that's the power of IBM, that as you visited our silicon facility, you can actually go touch. You actually ate a 2 nanometer potential.
Yeah. So again, there's another video.
Oh, I see. Okay. So now there's like 2 videos I need to watch.
Yeah. Oh, there's many more. Trust me.
Many more. So the fact that you've eaten the chip that is used, and you're talking with Sriram, who is developing the coolest model in the world right now, that's the power of full stack in our view.
So when I speak to developers who are playing with this stuff, either from first principles or further down the chain, I'm getting the sense of them that you have to be kind of like a software ninja to get into the guts of these things to optimize. And what they're really crying out for is the library stack to abstract it away. Absolutely. I mean, how many small, medium businesses don't have, say, the budget to go engage with a large company like yourselves, but still want to go do this? The tools still need to be in the ecosystem.
Absolutely, and that's why we've taken a very open approach. Look, I think the rate and pace is so heavy here that what you're talking about developer experience, you're right. There's a developer who can prompt their way through something simple. But do they have the skills to turn it into, there you go, turn it into a deployable piece of software that meets the ROI and has the latency? Yes. But I think we're going to see rapid innovation. There's basic questions on, I deployed this application, a new version of the foundation model came. What's testing here? How do I update? Will my prompt still work? Do I have to refine tune? So there's lots of those questions. But I'm confident our approach has been partner in the open. contribute to the open, invest in the open, because those tools are going to develop rapidly. And the demand is so high, my view is we're going to see rapid improvement in productivity when it comes to building AI applications.
It's interesting because most of the companies I speak to, I either categorize them as hardware, and they want to sell the hardware for a price, and they want the software to be free, or software, where they want to charge for the software and the hardware to be free. You guys sit in this space because you have hardware, you have software, but the main business idea is consulting on the top. Right. So that's
the real definition of full stack. Actually, all the way up to that.
Which consulting company has that depth inside the company, which can go all the way from silicon to be able to now
business value
as a, so that's the power of full stack at IBM. That's the IBM stack. And we continue to, and again, I want to say that we are partnering in every aspect of stack, including consulting.
Yeah.
We are very proud to be working with other hyperscalers as an example, right? Where we are working on deploying our models, helping our clients. Depends on what client want to do. They want to develop these models on-prem, in cloud, IBM cloud, other cloud. We are very flexible.
And I know you guys are very open about this sort of super cloud concept of wherever your models are, we'll go do it. I will put one challenge to you. I want to see more of the hardware side. You know I'm a hardware nut, and we saw the AIU last year.
Yes.
I want to see more.
Oh, you're going to be, later today when you come and see our new and improved Think Lab, you will be amazed on how much progress we have made. So just stay tuned.
You guys are going to have to check my socials to find pictures.
Something new for you to bite on.
Oh, yeah, maybe. So thank you guys for taking time out. I know it's actually really early in the morning as we're filming this, and you guys got to present later. Looking forward to that. Hope you've got a few surprises, but thank you.
Thank you.
Thank you.